Now see here biasing of diode. So this biasing, that means is here the connection of the diode with the battery. If you have taken a diode like this, that is a PN junction diode symbol I am using. This is the P type and this is the N type, and now connect this to the positive terminal of the battery here. Another way of connecting the diode is to in this way, negative terminal, P is connected to negative terminal. So see here in the first here, the P, this one here, P type semiconductor of the diode is connected to the positive terminal of the battery, and N is connected to the negative terminal of the battery. This is known as forward biasing. Now if you take this symbol here, this connection here, P side is connected to the negative terminal of the battery and N side is connected to the positive terminal of the battery. This is known as reverse biasing. So now we will do here the variation of the current in the forward biasing and in the reverse biasing. So how does diode work in the forward biasing and in the reverse biasing? So let us understand the working of the PN junction diode in forward biasing first here. So now what happened in forward biasing? Suppose you have taken here like this PN junction diode. This part is the junction region here where immobile charges are there. There are holes. Minority carriers are electrons here and majority carriers are electrons and minority are holes here. This is P type, this is N type, this is the junction part. Immobile charges are here at the junction. Now when we connect to this is the positive terminal of the battery and N is connected to the negative terminal of the battery. Now you will be seeing positive and negative. Because of this positive, you know, when the voltage is not, this has got the barrier potential here V naught. This is the height of the barrier potential and this is applied voltage is here V. So in this case, when this voltage is smaller, diffusion is not taking much because only outermost electrons are being forced to diffuse. But as you keep on increasing the voltage over here, you will be seeing here the more and more holes will be going to this side and more electrons will be coming to this side. So when you increase the voltage from here and this voltage become enough high to overcome the junction voltage or the junction electric field, then the diffusion current starts, and again due to the diffusion current diode start conducting. But it has got the variable resistance because this here the width of the depletion layer keeps on reducing with the increase in this voltage of the battery. But if you take the reverse side here, what happened here, the reverse bias? If you are taking in the reverse bias here case, so this is connected to the negative, this is connected to the positive. So see here, holes are being repelled to this side, electrons are being holes are attracted to this side and electrons are attracted to this side. Because of this, width of the junction becomes wider and wider. In this case, the resistance actually here, we can say an ideal diode has got infinite resistance, no conduction takes place. But because of the minority carriers, here the minority carriers are here the holes and minority carriers are here electron. So from N side, holes are the being repelled, being here to forced to move towards the junction, and from here electrons are being forced to move towards the junction. Because of that, current flows here. This current is known as the drift current here, but this current is here, it is very small in magnitude because of its, that is in the microampere actually. The reason is because this is due to minority carriers. So this current magnitude is very less, but at a certain voltage you will find in the reverse bias, when this voltage becomes very high, in that case at the junction electric field will become very high. Because of that, all the electrons or all the charge carriers from the valence shell of the atoms will be pulled away or pulled out, and because of that suddenly current increases. And because of that, there will be here, if the small voltage is applied or the small voltage is changed, you will be getting there is a large change in current. That voltage, at which voltage this is happening, that is called the breakdown voltage. So now let us study here about the characteristics of the PN junction diode in forward and reverse bias.